Jai Hind to all. This is Dr. Shivani Agarwal. Today's my presentation topic is process life cycle. That topic belongs of the operating system. So let's start the topic. So first, I explain what is process. Any active program known as process. So there is a process life cycle. When a process executes, it passes through a different states, and each and every state has a different work. So we know about each and every state of the process. So we start with the the initial state. So this is the initial state when the process wants to start or create a new process. Now, what is ready state? The process is waiting to be assigned to a processor, because each and every process wants to execute by the processor, but at the same time we don't give the every process to a processor at a time. So the process is waiting to assign to a processor. So the ready process are waiting to have the processor allocated to them by the operating system. So this is the ready state. In the ready state, each and every process has to be ready for the execution, and we have to give that particular process to a processor. When the processor is free, then we have to assign the process from ready to running state. Otherwise, the process is in waiting state. So what is running process? Once the process has been assigned to a processor, means the processor is free for assigning the process, for executing the process. So the process becomes from the ready state to the running state. Now what is waiting state? When the process want to the execution by the processor, or want to any input value by the processor, so the process becomes in the waiting state. So the process moves into the waiting state if it needs to wait for a resource, such as waiting user input, waiting for a file, or waiting for a processor. So it is in waiting state. Now what is the termination state or the exit state? When the process finish the execution, so it becomes in the termination or the exit state. This is the life cycle of the process. So we start the process from there. This is the initial state. Then the process becomes into the ready state. Ready state means the process is ready to be executed. So it is in ready state. But at this time, maybe the processor is free or not. If it is not free, so the process just begun in the ready state for the process execution. Then we have to move this process with the running state. When we move to the ready to the running state, when the processor want to execute the defined process, so it is the state changing from ready to running. Now when the running state is completed, then that means the process is completed, then we have to terminate that particular process. What is the waiting state scenario? Basically, when the process needs some file or need some input data, so at the time of the running, so that state becomes known as the waiting state. So the process moved from the running state to the waiting state, and at which time the process comes in the waiting state, the process still in the waiting state when the processor is not free for the different process executions. So till the process resides in the waiting state. So this is the basic process diagram. Now we have to move for the expanded diagram of the process life cycle. So this is the expanded diagram of the process life cycle. So in this life cycle, we start with the basic components of the process life cycle. This is new, ready, running and waiting. But we have to expansion in the waiting state with respect to the suspended blocked, suspended, ready. So these are the expansion of the process, and these expansions we define the number of schedulers as well. So we start with the expansion diagram of the process life cycle. So when the process want to start the execution, that means that this is the initial state. So this is same as the previous diagram. This is the new state when the number of process wants to be executed. So these are the ready for the execution. So this is the initial state. Then when the process admit or becomes the admission from the new process to the ready state. So, this is known as the admission process. This is the work of the long term scheduler. So, this is basically what? New to ready. So, the process start or initiate with the for the processor, and at this time the process is ready for the execution. So, this becomes in the ready state. Now, when the process goes from the ready to the running state, so it is the dispatching, at this known as the dispatcher. Basically, when the process ready from the running moves from the ready to the running state, so that known as the dispatching the process, because at this time the processor is to be allocated to the ready process. So, this is the dispatching, this known as the dispatcher. Sometimes when the highest priority processor becomes for the ready state, and at this time when the processor want to the execution for the highest priority process, so at this time the current running process paused or the blocked. So, it just blocked at that time, and sometimes the process needs some event or process needs some process or input file. So, that running process comes in the blocked state. When the processor needs completed that running file or that data that the process required, so that block state just begun to the ready state. The process move from the blocked state to the ready state when that event that the process want, that is completed. So, it moves from the blocked state to the ready state. So, this is the basic process of the process life cycle, but sometimes we have to suspend the process from the blocked state to the suspended block. How we do this? Actually, when the process have a more time for the file execution or some input file, so that blocked state becomes full. So, we have to just suspend some processes in the suspended block for a longer time. When the processor is not free from the running state, so we have just move on from the suspended block to the suspended ready rather than the suspended block to the blocked. So, this is the this suspended block process is a block diagram of that particular process life cycle when the processor need to be execution, but due to some the events or due to some file executions, we don't move the suspended block to the block. So, at that time that particular process, those are resides in the suspended block that move with the suspended ready state. So, this is the basic important point, that how we have to perform the suspended block to the suspended ready, because sometime the process waits for a longer time for the processor, but the processor not assigned with the suspended block to the block. So, this is the backend process that we have to move the suspended block to the suspended ready, and at this state the processor easily go to the ready state for the processor. So, at this time when the processor just move from the suspended block to suspended ready, then suspended ready to ready. So, at this state the process again request for the processor in the ready state, and this particular ready state when the process resides in the ready state, so it is easily dispatched by the dispatching process from ready to the running state. So, this is the basic diagram of, this is the expanded diagram of the process life cycle. So, these are the certain criteria that we have to define, that how the process move from the running to the block, and how the process move from block to the suspended block, and how the process move from the suspended block to the ready state or the blocked state. So, this is the diagram, expansion diagram of the process life cycle. The operating system schedulers. So, we have three type of schedulers. First is long term scheduler, second is short term scheduler, and third is the mid term scheduler. So, basically what is long term, what is short term, what is the mid term scheduler. So, Long-term scheduler, basically long-term, when the process move from the new to the ready state, so this is the admission process, and in this long-term scheduler, the process decides which job or process are to be sent to the ready queue. So that decide in the long-term scheduler that which process has need to want the processor for the execution. So process is an instance of a computer program, that already know that process is an instance of a computer program, and it is just a collection of instructions. So while a process is the actual execution of those instructions, so it is known as the active program. So the process known as the active program. So the ready queue has been loaded into the main memory and it is waiting the execution on the CPU. So this is the long-term scheduler, how the process needs to the execution and how the process admit from the new state to the ready state. So this is the long-term scheduler. Now the mid-term scheduler. Mid-term scheduler means the swap in and swap out process. What is mid-term scheduler? Basically, in this particular life cycle, in this state, the process becomes in the mid-term scheduler when the process move from the blocked state to suspended block or suspended block to the blocked state. So this is known as the mid-term scheduler point. So what is the mid-term scheduler? Basically, it referred in swap in swap out because for the some event, the process move from the waiting state to the suspended waiting. So that that scheduler known as the mid-term scheduler. Present in all systems with the virtual memory, we use that particular scheduler. So with the virtual memory, the computer can look for areas of RAM that have not been used recently and copy them onto the hard disk. So the free space in RAM to load to the new applications. So basically, the midterm scheduler just belong for the swap in and swap out process from the waiting state to the suspended block states. Now, what is the short term scheduler? When the process move from the ready state to the running state, so that particular time slot known as the short term scheduler. Now, move with the FCFS scheduling algorithm. What is FCFS? The name of the FCFS is known as the first come first serve. So, it is a very simplest scheduling algorithm. In this algorithm, we have just give the process first process when the process demand the request of the CPU. So that particular first process we have allocate the CPU first. So that policy is a very easy or simplest mechanism. So we have assigning the process at the first time that the process want the CPU. So in this, the process enters the ready queue and the PCB is linked on the tail of the queue. So at this time, the processor just give the processor for the ready state. So let's take an example. There are 4 processes P0, P1, P2, P3. Each process has the arrival time and the burst time. This is the execution time. What is the execution time? Basically, P0 need or required 5 time for the execution. So this is the 5 is the execution time of the P0, 3 is the execution time of P1 and 8 is the execution time of the P2. These all the execution time known as the burst time. How much time the process needs the processor. So P0 need the processor at time 5, that needs the processor for the 5 minutes, and P1 needs the processor at 3 minutes and P2 needs the processor at the 8 minutes. So basically, these are the arrival times. P0 comes at time 0, P1 comes at time 1 and P2 comes at time 2, P3 comes at time 3. So we just plot Gantt chart for these particular algorithm for the FCFS. So what is Gantt chart? Basically, Gantt chart is a horizontal bar chart that is developed in 1917 by the Henry L. Gantt. So these Gantt chart present the process at at which time the process give the processor, and at what time that the process execute by the processor. So this is the initial time and the execution time of the each and every process. So in the Gantt chart, because P naught arrived at time 0, because by using the FCFS, because FCFS is a non-preemption algorithm. What is preemption? What is non-preemption? Basically, preemption means we don't preempt the process till the process executed. So this is a non-preemption. Preemption means we have a preemption means we just give the processor for every process for a given time. So that given time fixed by the mechanism or the algorithm that you have to use. So P naught start at time 0 and till 5 minutes, because P naught burst time is 5 minutes. So P naught need to be executed with the 5 minutes. So we initially start with 0 and end with 5. So this is the complete process for P1. Now P2, because at the time 5, these all the process comes in the ready state, because P1 also comes at the arrival time 1, P2 comes 2, P3 comes 3. So at this the execution of P naught, these all the process comes in the ready state, but we have to allocate one by one. So because the FCFS, because P1 comes first with rest of P2 and P3. So we have to allocate the processor for P1 at time 5, because this is the non-preemption mechanism. So we don't preempt any process in between when the processing time finished. So the processing time of P naught is 5. So we can't preempt that particular P naught process in between for the execution when each and every process, that is P1, P2, P3 is come at the time of execution of P naught. So we can't preempt these processes, this process P naught when the P1, P2, P3 processes arrived. So we have to give every process to the processor one by one. So after P naught we have to just put P1, because after P naught we have to ready state the process P1. So we start the process P1 at the 5 time, and then P1 needs the execution for the 3 minutes. So we have just give the 3 minutes from 5 to 5 plus 3, so it is 8. So P1 limit of the execution is till 8, because we start with 5 and it required time is 3. So 5 plus 3, so 8 is the execution time of P1. Same as P2. P2 assigned the processor at time 8, and here we have to execute the P2. We need the execution time for P2 is 8. So just add 8 with 8, so it is 16 for the execution of P2. Then we have assigning the process of P3 at time 16, and we have at this time 16 P3 allocated the processor. So it is in the running state at this time, and we have to just terminate that P3 process. So it needs the execution time is 6. So we add 16 plus 6, so it is 22. So what is the waiting time for each and every process? So when the process P naught becomes, so directly we have give the processor at time 0. So the waiting time of the process P naught is 0. So it is basically 0 minus 0, so it is 0. For the P1, because P1 comes at the time 1, but it assigned the processor at time 5. So basically 5 minus 1 equal to 4. So we have to assign the processor for the process P1 at time 4. So the wait at time 5. So the waiting time for this particular P1 is 4. Same as P2 and P3. P2 assigned the processor at time 8, but P2 becomes at time 2. So 8 minus 2, it is 6. So the waiting time for these processes are 0, 4, 6 and 13 accordingly. The average waiting time for these processes are, so we have to add all the waiting time and divide by the number of processes n. So this is 0 plus 4 plus 6 plus 13 divided by n, the value of n is 4 in this case. So it is 5.75. So this is the FCFS basically. Now this is the second question. In this question we have a burst time is, there are 3 processes P1, P2, P3 and burst time of each process are 24, 3 and 3, and each and every process arrived at time 0 in this case. So when each and every process have assigned arrived at time 0, but we follow the order is P1, P2, P3. So when we follow the order is P1, P2, P3, so first we assign the processor at P1 for P1. So when we assign the processor for a process P1, so its starting time is 0 and the execution time, that is burst time, is 24. So and the process of P2 and P3 needs only the 3 minutes for a processor for the execution, but because the arrival process order is P1, P2, P3, so we assigned accordingly the order. So first we assign the processor for process P1, so it is 0 to 24 the execution of the P1 because it needs the execution time is 24. So in this particular question we have a problem. The problem is that the longer the minimum time required for the processor, that is by the P2 and P3, but according to the order we first assign the processor to the process P1. So this problem known as the convoy effect. So what is basically convoy effect? Convoy effect means short process behind the long process. That means what? P2, P3 demand, in this question P2, P3 demand the processor for 3 minutes and P1 required the processor for 24 minutes. So we just assign the processor for P1 first due to the ordering. So P2, P3 required the very small time as compared to the process P1. So we assign the processor or hold the processor by the P1 for a longer time as compared to the P2 and P3. So this problem known as the convoy effect, this problem comes in the FCFS. So this is basically the motive of this particular question, ki how the convoy effect is and what is the convoy effect, how we have to remove that particular convoy effect. So when the processor assigned to the process P2 or P3 first as compared to P1, so this convoy effect is removed automatically, but because of the ordering of the process execution, there are P1, P2, P3, so we can't do this. So the convoy effect in this particular question is activated. So this is same as the waiting time, and the average waiting time is calculated as the previous question. So the main motive of this particular slide is this. Now in the same question, when we have to just change the ordering of the process because of the removal of the convoy effect. So first we have to execute the process P2, then P3, then P1. So in this question the convoy effect is removed because the processes smallest time processes are not wait for the long time process. So this is the basic problem of the FCFS. So this is the convoy effect is activated in the FCFS when some time the processor assigned for a longer time process. So this is the basic scheduling algorithm, that is the FCFS. So I think thank you so much for this particular.